everyone. Thanks for clicking on video number 2 for section 3.1. I think you will find it worthwhile and helpful for you to understand this material. I encourage you to take good notes, thorough notes, because our tests are open notes. So take some good notes so you have some help when you need it. And the more you pay attention now, the better you're going to understand it, and the less you'll even need the notes in the future. So active participation during this video is appreciated and important. All right, so we're going to move ahead, continuing on with this idea of functions and function notation. Now that we know functions, for every x value, you can have one y value, no more than one. There are special ways, special notation we use to help you recognize, oh, this is a function, okay? So I'm going back to this idea of temperature of hot cocoa that we talked about in chapter 1. We learned in chapter 1, temperature of hot cocoa. Well, we're going to put time along the x-axis and temperature along the y-axis, because we know that our independent variable goes on the x-axis and our dependent variable is considered our y value. And remember, time is considered the independent variable because time happens no matter what. Now, temperature of hot cocoa, it depends on the amount of time it's been out of the microwave. So the temperature depends on the time. So that's why the temperature is the dependent variable. And then we talked a lot about how maybe it comes out of the microwave at whatever temperature, I don't know. And then you take the temperature maybe at 1 minute intervals or 30-second intervals, whatever you decide, it will quickly cool off and then level out. And we talked about in chapter 1 how that's considered long run behavior, where it'll end up being over time, the temperature won't change. And in the case of hot cocoa, it will level out at whatever the temperature of the room it's in. So maybe 70 degrees, maybe 72, maybe 68, however you keep your house. Okay, so the thing I'm going to add to this now is give it just a little bit of function notation. Basically here, to make things a little more proper with function notation, the y-axis is the only thing that changes, and instead of saying y, we use a term f of x. Because what it's saying is that the value of y, so in this case the temperature, depends on the value of x. So it's like depending on if we say we're at 1 minute or 3 minutes or 10 minutes, whatever number goes in here will determine your y value. You need to know your x to be able to figure out the correct temperature. If I just asked you what's the temperature, you'd say, well, it depends. It depends on how long it's been out of the microwave. So this notation, saying f of x, clues you in that you're dealing with a function instead of just saying y, which could be anything at all. So it seems kind of fancy, but that's really all there is to it. So let's try another one. Here, the price of candy goes up $2 every day. So I would say the price depends on the amount of days the candy has been for sale. So as usual, time is going to be that independent variable. It happens no matter what. So that will go on our x-axis. And it talks about going up $2 every day. So it would make sense for this graph, for the scale, to be number of days. Okay? Then the y-axis, so this was the x-axis, that y-axis talks about the price. And it says that it starts at 150, so maybe we put a mark here at 150, and then it goes up $2 every day. So maybe our scale here, we're dealing with money, will go up by $2. That could make a nice easy looking graph. You could even start plotting some points. It starts, and originally, before anything happens, we're at 150. That's like your u sub 0 in a recursive, and then it'll go up to 350, then up to 550, then up to 750. This particular function will be discrete. I wouldn't connect those dots because it's not a different price at like 1.5 days. It just jumps up $2 every day. So the only thing, so like if I asked you to write like an equation to represent this as if it were continuous, you'd say, well, the slope goes up $2 every day, and then it started at 150. So y equals 2x plus 150 would be an equation representing if you had a line going through these points. Now to change it to proper function notation, all you do is replace the y with f of x. So you could think of over here as the y-axis or think of it as f of x. This still gets to stay plain old x. So this right here is considered proper function notation. Again, it's just a really easy little simple switch, but it just lets you know that you're dealing with a function. All right, sometimes a function is defined by a graph. So if you look here, I can see it says y equals g of x, okay? So here I would definitely think of the x-axis still as x, but maybe I think of the y values as g of x. The y value depends on the x. So I definitely think this also looks like a function in the sense that it passes the vertical line test. So if I do the vertical line along the red function, it will only ever hit the red function once. So visually, I see it looks like a function as well, and because of this notation right here, that also clues you in that you're dealing with a function. So here's some questions. Oops, that's not what I wanted to do. Here's some questions you might be asked. Let's see. No. Yep. Some questions you might be asked on a quiz or a test or a homework. It might say something like, find g sub 1. And you have to tell me what that equals. So to say that out loud, you'd say g sub 1. And what you're asking, what it's asking you, it's saying when x is 1, what is the value of y? Is how you would think of that. So I would say, all right, well, I'm going to go look over on my graph. When x is 1, 2, 3, 4, what's happening in my graph? Well, it's right up here. So when x is 1, it looks like g of x, my y value, is 3. So 3 would be my answer. Let's try another one. This one says find g of -2. If you can remember that what's in parentheses is always your x value, this will be a piece of cake. So let's look on the graph. Well, when x is -2, oh, my graph, it's right there at 0. All right. So it's kind of like you're used to writing these as ordered pairs, 1, 3, -2, 0. You're used to thinking of them as x, y. Now you could start thinking of them as x, f of x. It's just a little simple thing, but it'll help. You might also be asked to question this. Find x when g of x equals 0. Well, this is saying, what are the zeros? When g of x is 0, remember you could also think of that as, well, what is x when y equals 0? So I'm going to go and look at my graph. Well, on the red graph, when y equals 0, we're right there. That's really the only place it's happening. So find x when g of x equals 0. Well, looks to me like x equals -2. Here's another one. Find x when g of x equals 2. So you could think of it as find x when y equals 2. So when I do that, well, when does y equal 2? It equals 2 right here, and it equals 2 right there. So this one would actually have a couple of answers. So find x when g of x equals 2. I would say, well, y equals 2 when x is 0. It also equals 2 when x is 2. So that would have 2 answers. All right, so sometimes a function is defined by a graph. We had to look at a graph to answer questions. Sometimes we're not given a visual picture at all, and a function is defined by an equation. So here you can see your equation. We know we're dealing with a function because this fancy terminology of f of x. This could just say y equals 2x minus 5 over x minus 3, but the fact that f of x was put there is letting you know you're dealing with a function. This is worth writing down. To solve this, all you do is replace each x with the x value they're asking for, and then you evaluate it. So they're saying, find f of 8. Okay, well, if I rewrite this, every time I see an x, I put an 8 in. Then all there is to do is simplify that right-hand side. All right, well, PEMDAS, 2 times 8 is 16. All right, now if I just clean that up a little bit more, 16 minus 5 is 11, 8 minus 3 is 5. So that tells me that f of 8 equals 11/5. That's a little bit hard for me to visualize. Maybe it would help if I changed it to a mixed number. You wouldn't have to do that. You know, to be honest, in Honors Algebra 2, to keep it as an improper fraction would be considered the best. But just for the sake of visualizing it, this is saying when x is 8, y or f of x is up at 2.5, okay? So that would be your answer there. That is how you handle when when the function is given to you in an equation form. And then back here is you know how to handle when a function is given to you visually with a graph. That is it for today's notes. Hopefully you learned something. See you in class tomorrow.